let him cook. Son, let him cook!
An amazing teacher. I love math. Thanks, Mr. Ing. Like and subscribe.
Alright, I'm going to explain this method called chunking factoring, and then I'll also show you that it actually works even if you don't understand the chunking. Okay? So chunking works when you focus on the A and the B. Class, what two letters do you focus on? The A and the B. What you're trying to do there is find the greatest common factor for these two. What's the greatest common factor? 9? 3x. Okay, watch this. 3x is my greatest common factor. If I do this expression squared times 7 times that expression plus the 10, because 3x squared is 3x times 3x, which gives you 9x squared, and 7 times 3x gives you the 21x, and there's the 10. Okay, so what do you do here? In higher level math, when things get complicated, you can do a substitution. Everyone say substitution? Instead of writing 3x, I'm going to write, I don't know, any variable you want. You can pick z. So every time I see 3x, I'm going to write z. Z squared plus 7 times z plus 10. And essentially what you have here now is you just have like a quadratic equation now that you can factor. Class, A times C? Pretend the parentheses aren't there. That would just be 10, right? A value is 1, C value is 10. What's your B value? 7. So again, if you're getting confused with the variable Z, just think it's an X. Two numbers that multiply to be 10, but add to be 7. 5 and 2. So I would write the 5 and the 2. So now I have z plus 5 and z plus 2. But we did something, didn't we? Class, what did the z equal? 3x, right? So every time I see z, now I'm going to write what? 3x. So now I have 3x plus 5 and 3x plus 2 is my answer. So let's review the chunking method. The chunking method for factoring only works when you have which two letters? A and B have what? Have a greatest common factor. Okay, here's the good news. Xbox method is so wonderful, you don't even need to use this chunking method. But if you use this method,
who's that dummy? Don't text me, it's not fair. Huh?
So the Xbox method says even though you may not recognize this chunking method, you can still do the problem. Let's do that together. Class, why do I have to use the box on this side but not on this side? Talk to your partner, 5 seconds. Let's see if you get it. Alberto, why did I use the box on the right side but not the left? Because I just felt like it. There is a concrete reason why. I'm going to call back on you. Jeremiah, why did I put the box on the right side and not the left side?
To be honest, I wasn't paying attention.
Joe?
Is it because there's a number in front of it?
There's a number in front, okay. So when there's a number in front, when the A value is greater than 1, you must use the box. Jeremiah, when do you use the box?
When it's greater than 1?
When the A value is greater than 1. Alberto, when do you use the box?
When the A value is greater than 1.
Notice on this one, my A value is actually, with the substitution, my A value is just 1. That's why I only use the X. Class, what's A times C? 90. Class, what's my B value?
21.
Okay. I need to think of two numbers that multiply to be 90 but add to be 21. Now, if you get stuck like I am, you can just list out all the factors of 90. 90 times 1, 30 times 3, 45 and 2.
15 and 6.
Any others? And you guys said what number?
15 and 6.
Let's use it. Okay, some students have had some struggles filling this in now. With your partner, take 10 seconds. I want you to fill in the box now. Ready, set, go.
Can I erase my name?
Alonzo, what do I write here? On the top here? Nine x squared. Alonzo, what do you put in the bottom left?
Like 6 different people like that.
15x. What do you put in the top right? Always? 6x. He added the variable x because you're splitting the terms here. And Alonzo, what goes there? The last term, 10. Alex. Greatest common factor? Class, what's the greatest common factor? 3x. How about this direction? 3x. Greatest common factor?
2.
Greatest common factor? 3x plus 5. 3x plus 2. Look. Same answer, right? Alright, factor each expression completely. That's what I'm basically going to tell you for your quiz, but it says using the chunking method. Remember, the chunking method, you can actually use the chunking method, or you don't have to. All you want to know is if you can factor. Let me show you guys how to use Xbox. There is no greatest common factor, even, odd, so I have A times C gives me 12. My B value is 8. Class, my two numbers are 6 and 2. 6 and 2 are splitting the middle term 8x, so this will be 6x and 2x. The first term is 4x squared. This one is a 3. And then now I can just take out the greatest common factor. This one will be 2x plus 1 plus 3, and then I can double check by multiplying. 4x squared, 2x, 6x, and 3. My answer is going to be 2x plus 1 and 2x plus 3. If you were using the chunking method, do that one really quickly for you. I need to put something in the parentheses to be the power of 2 to be 4x squared. That'll be 2x. So the power of 2 has to go on the outside, and this would be 4 times 2x plus 3. And then your variable, like your square, equals 2x. So I'd have square squared plus 4 squared plus 3. And then when you factor that, that'll be square plus 3 square plus 1. And then if you do the substitution for your square, you'll get 2x plus 1 and then 2x plus 3. That's number 14. Raphael, read the directions for us, please. Raphael, if you had to describe to someone the chunking method, which terms do you look at? The first two is correct. The chunking method says look at the first two. Now, Raphael, if you didn't see the first two, are those numbers pretty big? Yeah. A times C, 25 times 12. You're probably looking at what? Is it 300?
Yes, sir.
All right, Raphael, what is the greatest common factor of our first two terms? 5x. Tell me what's right. Focus. Okay, now what?
So 5x parentheses squared minus 7 5x plus 12.
And what's the special variable you used, Raphael? Z is equal to what?
5x.
Good job, Raphael. Erica? Every time we see 5x, what are we going to write now? Okay, the first one we're going to write z squared. So let me get that there. Tell me what to write. Correct. Good job, Erica. Josh? We're going to factor that. Josh, do you need to use the x, or do you do it in your head? You use x? Okay, let's use the x. Joshua goes on top of the x right here. A times c, which is 12 is correct. Correct. Josh, we're looking for two numbers that multiply to be a times c, and those same two numbers add to be negative 7. Negative 4 times negative 3. Josh, tell me what to write on this side over here. What letter? Z. Negative 4. So that comes from over here. And over here, z negative 3. Thank you, Josh. Sarah, are we finished yet? Tell me what's right now. So every z value you're going to substitute back in now. And your answer is going to be 5x minus 4 times 5x minus 3. Again, you can always interchange those. Raise your hand if you got that. Good job. C3 says, factor each expression completely using the chunking method. Remember in class we talked about how you don't actually need to use the chunking method. All I'm going to ask you to do is just factor. So I will show you both methods. I'm going to use Xbox first. Number's going to be kind of big, right? A times C, get my calculator, 121 times negative 12 gives us 1,452. And my B value is negative 44. Well, guess what? I already know what one of the factors are. I'm not saying it's correct, but I already know it's 121 times 12. And let's just say I use 121. That looks like a perfect square. So that's 11 times 11. So let's say 11 times. That gives us 132. Class, are we getting any closer? Nope. Let's try 24. No, that didn't work. What's my trick to this one? 1452. Show you what I'm doing with my divided by x, and then
negative 66 plus 22.
Say again.
Negative 66 plus 22.
Is that your factors you're saying?
Yeah.
66 and 22. Let me show you guys how I'm using my graphing calculator, and I actually can use this on your other calculator. I haven't figured that out yet, but table set 1. Any whole number, so now it has 2 times 726. I'm not going to list out all of these, but it basically punched out all the factors for me. And anytime it's a whole number, 6 times 242. 132 times 11, which we got. So I'm just looking for any other whole numbers. 12 times 121. And I have 22 times 66. And 33 times 44. Class, which one am I going to use? 22 and 66. Which one is negative, if any? Negative 66 plus 22 gives me negative 44, so I have negative 66x and 22x. I'm going to have 121x squared and then negative 12. So the first term always goes in the top left, the last term always goes in the bottom right, and these two terms always go diagonally. Now I just need to get my factors. Class, what do you think the greatest common factor there is? 11x. And here is a hint if you think it's by chunking. The numbers on the outside will always be the same. If you know it's chunking method, these numbers will always be the same. So this number is going to be what? 11x. 11x times something equals 22x. 2. 11x times something equals negative 66x. Negative 6, and negative 6 times 2 gives us negative 12. So 11x plus 2, 11x minus 6 is our answer. Now, what was the challenge for us to do Xbox? the numbers were super big, weren't they? Okay, let me show you guys chunking method. So I have 121x squared minus 44x minus 12. So in parentheses, I need to have the same number. So that'll be 11x, and then the square on the outside, negative 4 times 11x minus 12. Here's my substitution. Pink box equals 11x. So now I have the box squared minus 4 times the box minus 12. The chunking method, what it's done is instead of using an a value that's really big, you've basically made your a value what number now? 1. A times c is negative 12. B value is negative 4. Two numbers that multiply to be 12 but add to be 4. What two numbers? 6 and 2. Which one is negative? So now I'm going to have 6 and positive 2. So I just put the box back there, right? Box minus 6, box plus 2. And then we just do our substitution again. Your box is equal to 11x. Raise your hand if you thought Xbox was easier. Raise your hand chunking was bigger, or easier. In this problem it was, but I wanted to prove to you can actually do both methods. What did you guys get for, what do they have in common?
7.
So tell me what to write. 7x squared, right? Plus 9, 7x plus 18. And what variable did you guys use? Z is equal to what? So we're doing the substitution. So every time I see 7x, we're going to write. So I have z squared plus 9z plus 18. Okay. Now these numbers are smaller, and now we can use our x factoring. A times c. 1 times 18 is 18. My b value? 9. Two numbers that multiply to be 18, but add to be 9. 3 and 6. So now I have z plus 3 and z plus 6, right? So instead of writing z, we're going to write 7x. So I have 7x plus 3 and we use factoring by chunking. Now, do you think you would want to try that without that? 18 times 49, and you have to list out all the factors. You probably could, probably wouldn't be fun. C5 says to factor each expression completely using the chunking method. Again, I'm not going to tell you how to factor it. I'm just going to tell you to factor it. And this one says the chunking method, and you don't actually need to use it. Don't need to. But I'm first going to show you guys Xbox, and then maybe you guys will want to do chunking. So let's try it. A times C is negative 99. B value is 30. I'm going to list out all the factors of 99. I think we can do that. 99 times 1, 3 times 33, and it looks like that's the answer, right? So let's put that in. 33 and 3. If I do a minus, this multiplies to be a negative, but that adds to be a positive. I'm going to put in the top left, the first term always goes there. Last term always goes in the bottom, and then these two numbers that we just found, we're going to add an x. Next, we're going to try to find our greatest common factor. 3x, 3x, -1, and this one looks to be positive 11, right? And you can just multiply 9x squared, -3x, 33x, -11. And so my answer is 3x minus 1, 3x plus 11. Raise your hand if you got that. Alright, let me show you guys the chunking method. Again, you don't need to use the chunking method, but it might be super helpful. What is the chunking method? It basically says, can you put a number in the parentheses? So when you square it, equals 9x squared, and the same number that you put in the parentheses times something will equal 30x. So I'm going to guess that number is 3x. Because 3x squared gives you 9x squared. And then something times 3x gives you 30x, so that will be 10. And then I just have the minus 11. I'm going to do my substitutions. So my box is equal to 3x. So no longer am I writing 3x, I'm just drawing a box. Then my x method, a times c is -11, b value is 10. Two numbers that multiply to be 11 are 11 times 1. And this is negative, so this will be a -1. So my box plus 11 and box minus 1. And then I just put my box back in there. So you get 3x plus 11 and 3x minus 1, which is actually the same answer, right? What's the point of the chunking method? It just makes your a value from 121 and goes down to 1. So it works. You work with smaller numbers. This one was definitely quite large. Question C6 says, factor each expression completely using the chunking method. Now, the chunking method is a particular method, and what it is it just helps you factor a little bit easier. Let me show you guys the chunking method. So if I look at those two, I need to put something there in the parentheses, and it has to be the same thing. Class, what do you think it is?
13.
Well, I want to show you this new trick on the calculator I just learned. So here's this calculator. Give me another week, I'll try to find an emulator so I can show it to you on the computer screen. So the first thing I found is that if I press mode, and usually you're on the 1, but I'm going to move it to 3. And what I'm going to type there is I'm going to type in 169, but I'm also going to divide it by x, a variable. And x of mine is in red, so that would be alpha, and then the closed parentheses. And then if I press enter, or equals, I don't need g of x, you press equals again. And it tells me where do I want to start, I'll say 1. And where do I want to end, I'm going to do 15. And what do steps are just kind of like, how is it moving? So essentially what it's doing is it's taking 169 and dividing by 1, the answer is 169. 169 divided by 2. Class, is that a factor? No, because there's a remainder. Now if I keep going, there it is. 13 times 13 is one of the factors. So although your brain works nice, calculators can also be super helpful as well. Not doubting and then you can change it to go, but it gives me an idea at least where to start from. And that was actually super helpful, because if I know it's 13, and this one's 13 times 10, I'm probably going to put in 13x in there. Yep.
Isn't it when chunking you always use the square root of the first?
That is another method. I like that. Angel recommended taking the square root of 169, and you'll actually get 13. Here I have 13 times 10, so that's why I'm going to put a 10 outside, and then plus 24. And then you can also use your favorite variable, or you guys like using a box. So my box is going to be equal to 13x. So I'm going to get box squared minus 10 box plus 24. What this substitution has done is changed our a value from 169 now to 1. And if I just use my x, a times c is 24, b value is negative 10. Class, what are the two numbers? 6 and 4. Negative 6, negative 4. And then I just do the substitution again. So you will get 13x minus 6, and then 13x minus 4 is your answer. Raise your hand if you got that. Good. Now let's say you didn't see the chunking method. Remember, I'm not going to ask you to use a chunking method. Just think about it. It's just another way of doing a problem. We've been using the Xbox method, so let's do that. This is going to get really big, right? 169 times 24. And that gives you 4,056. And I need those numbers to add to be 130. I already know what two numbers are. 169 times 24. And if you look at it, if you subtract those, that's actually really close, isn't it? That gives you 145. So really close. So something really close to that. Did anyone find it? 9?
I can do that by addition.
Anybody find the number?
Yes.
Two numbers that multiply to be 4,056, but add to be 130. What number did you find? Yeah. 78. Is that what you said? And the other number? 52. Looks good. So if I go to 52, mine has 78 on there. Good job, Eric. And are those both positive or negative? Those will have to be negative, right? Negative 130. And so now if I put this into my box, I have 169x squared. 24 is the last one, and then these two go there. 78 and negative 52x. And just like we've been doing, if it's this number that's the same, these two numbers will always be the same there. Greatest common factor there? Negative 4, so negative 4 times 13 gives me negative 52. Negative 78 divided by 13 give us negative 6. And then those in red are actually the same in our box. Say again? You can. He's asking, can one of these be negatives, right? Yeah, I recommend that these never be negative, because your answer is always, they normally have these as positives. So try to keep these always positive. Okay?
Yes, Sophia?
Can I tell you a math joke?
Sure.
Okay, what did one math book say to the other?
What?
Don't bother me right now. I have my own problems.
I'm dead.